Hello everyone, another video on number system. Now in this video, I would be talking about calculating the remainders. You know what? I can bet my life on this particular concept that it will be part of your examinations. Whenever you'll attempt an aptitude examination, there will be a question based on finding out the remainders. Now, I'm not talking about simple division such as 7 divided by 2 and then we get the remainder. I'm talking about if I get a bigger value, let's say for instance 13 to the power 12. Yeah, 13 to the power 12, and then I ask you if I divide it by 7. So the complete expression gets divided by 7, and then you have to find out the remainder. You understand? 13 to the power 12. Now this is itself a bigger number. When I divide this complete number by 7, what do we get as a remainder? So these type of questions are part of the examinations. Let's check it out.
So to give you a quick overview of what kind of questions we get, let me write a quick question on your screen. So if suppose I write 2 raised to the power 99 divided by 7 and we have to find out the remainder in this case. Now here's something that looks a little difficult or something which will require time, because we cannot even calculate 2 raised to the power 99 in the exam itself. It becomes a tedious task and we may get a wrong answer. Then whatever the value comes, we have to divide it by 7 to find out the remainder, which means it becomes a cumbersome task. But in the aptitude or in the competitive examinations, we barely get few seconds to answer this question. So then what should be our approach to answer this? Let's see. I'll explain you the entire trick, but for that, we need to achieve two simple objectives. One is we will be writing the numerator, which is 2 in this case, in the form of denominator. That's the first thing that I'll try to achieve. And the second thing is we'll try and get digit 1. I repeat, there are two steps that we have to achieve. One is numerator in the form of denominator, and we'll try to achieve 1 from somewhere. So let's see what we can do over here. When I'm going to write 2 to the power 99 as 2 cubed to the whole power 33 by 7, I am trying to achieve either of these two cases. So by writing 2 raised to the power 3 to the whole power 33, I have not violated any of the mathematical concept, because 3 multiplied by 33 will again give me 99. Now what can be my next step? I know that 2 to the power 3 is 8, and 8 can be written as 7 plus 1 to the whole power 33 divided by 7. Now you would be able to relate it more. I have written the numerator, which was 2, in the form of denominator. You can see that my denominator is 7. I have represented my numerator in the form of 7 now. And my second statement was try and get 1 from somewhere. So I have got a 1 as well. Now let's see how quickly can we get the answer. So what are we trying to find out here? We have to find out the remainder. Now please understand, since we have 7 in the denominator and 7 in the numerator, this 7 will play no role in the remainder. I repeat, this 7 will play no role in the remainder, and hence I can ignore it. I have used the word ignore. I am not cancelling it. I cannot cancel it mathematically, but I am ignoring it because there is a 7 in the denominator, and hence this 7 will play no role in the remainder. To help you understand this further, let me take a small example. Let me write it this way: 2 cubed to the whole power 2 by 7. So instead of 33, I am taking 2 to help you understand this better. Now what is 2 cube? 2 cube is 8. 8 square by 7. What is 8 square? It is 64 by 7. 64 by 7 gives me 1 as the remainder, because 7 nines are 63. Now let me do it in the other way. 2 cube can be written as 7 plus 1 to the whole power 2 by 7. As I said, there's a 7 in the denominator, 7 in the numerator. I can ignore it. What am I left with now? 1 to the power 2, which is 1 by 7. And what do I get? I get 1 as the remainder. There can be one more approach to it. Let's see what. So 2 cube is 8. 8 is 7 plus 1 to the whole power 2 divided by 7. Now this is in the form a plus b whole square. So I can actually write a square plus b square plus 2ab and completely divisible by 7. Now you can always say that this 7 will not give me any remainder because there's a 7 in the numerator, there's a 7 in the denominator. Similarly, this expression will also not give me any remainder because there's a 7 here and there's a 7 here. So what will give me remainder? It's only 1. And that's what I have done here. I have ignored 7 and I have got only 1. So I hope this is quite understandable. And now when I ignored 7, this looks more meaningful. So what am I left with? I'm left with 1 to the power 33 by 7, which is nothing but 1 by 7, and which gives me 1 as the remainder. Which means 2 to the power 99 by 7 will give me 1 as the remainder. I hope this makes the concept more clear. And for those who do not understand how come 1 by 7 gives me 1 as the remainder, I will do it in the best simplified fashion. 1 divided by 7. 7 zeros are 0 and we get 1 as the remainder. Why I have explained this in such a silly way? Because I know many of the students have this doubt in their mind that how come 1 by 7 gives me 1 as the remainder. So this is what we have achieved. Now I will address some of the doubts which are going through your minds while you are watching this video. And that is, how did I converted 2 to the power 99 to 2 to the power 3 to the whole power 33 only? Why not in some other way? And to answer this question, we will take one more example wherein we will solve a single question in two different ways and we will still achieve the same outcome. Let's see what it can be. So suppose this time my question is, I'm picking some easy digits at the moment. This is my question. 3 raised to the power 199 by 7 and we have to find out the remainder here. Now bluntly, without doing any thought, I will be solving this question in two different ways. One in which I have taken 3 square and the other in which I have taken 3 cube. Let's do it in both the ways. Denominator always will be 7. That's how the question looks like. Now when I'm writing it as square, outside on the bracket I have to put 99 because I have to achieve 199. Remember, 199 is broken, therefore 99 multiplied by 2 gives me 198 and there is one more 3 which is pending. So I'll write it this way, and I hope you all would be knowing when base is same, powers get added. Therefore 99 multiplied by 2 becomes 198 plus 1 gives me 199. Let's do it here as well. So I'll get 66 on the outer side and 66 multiplied by 3 gives me 198 and there's one more 3 here. Please understand, when we are doing the trick, we can't violate the mathematical concepts. Let's take it forward. So what is 3 square? 3 square is 9. But if you remember, I have to write my numerator in the form of denominator. That's what I do. So I write 9 as 7 plus 2. Wherein 7 is in the numerator, 7 is in the denominator, I can ignore it. I end up getting 2 to the power, please remember this is 2 to the power 99 multiplied by 3 raised to the power 1 by 7. I'll not take this ahead as of now. Let's solve this part first and then we'll come back to it. Now 2 raised to the power 99 multiplied by 3 raised to the power 1 divided by 7. We already got an answer to this question in the previous slide. 2 raised to the power 99 by 7 gave me 1 as the remainder. So I can utilize it directly. If you want, you could have solved it. So what do I get? I end up getting 3 by 7, which is 3, which means my remainder for this question is 3. Such a easy thing. I hope you got it. Now let's take it this way. So 3 cube is 27. So just for the sake of better clarity, I would write it as this way. Now 27 can be written as 28 minus 1 to the whole power 66. Now many of you would think, why have I written 28 minus 1? Because 28 is a multiple of this 7 and hence can be ignored directly. Any multiple of 7 will not give me a remainder. Now I'm left with minus 1 to the whole power 66 multiplied by 3 by 7. Please understand, we can't ignore this sign. We have to consider it. So minus 1 to the whole power 66 minus 1 to the power even number will give me plus 1 multiplied by 3 by 7, which will give me 3 by 7, and that will give me 3 as my answer. So as you can see, irrespective of the transformation, my answer will be the same. It will never be different. That's how it is. Now from this particular explanation, here comes a question. Suppose over here, had it been minus 1 to the power odd number by whatever. Let's assume that everything remains the same except this number being 66, I would have an odd number. So what would happen? Minus 1 to the power odd number would have been minus 1 multiplied by 3 by 7, and this would have been minus 3 by 7. Now many people feel stuck here. Don't worry, dear friends. This is nothing but a remainder of 4. When there's a number which is a negative value and we have to find out the remainder, you simply add the numerator and the denominator along with their signs. I repeat, you simply add the numerator and the denominator along with the signs and you end up getting the answer. This can be better understood by the concept of remainder. What is the remainder? Remainder is the number which can be removed to achieve, let's say for example, over here, this value 3 to the power 199 minus 3 will be completely divisible by 7. That's what the meaning is. And if I explain it with an easier example, for example, I have, let's say 17 by 7. I know that the remainder would be 3, which means if I remove 3 from 17, I'll get a value which will be a multiple of 7. But at the same time, I can also add some value to it, let's say plus 4, so that the number that becomes a complete multiple of 7. So which means either my remainder is 3 or my remainder is minus 4, because we are adding 4 to it. That's what I was telling you. If you get negative remainder, you simply add the numerator and the denominator. You will get the positive remainder as the answer. I hope this is clear to everyone. Let's take one more question for better understanding. Now this time, instead of a single digit number, what if I give you, let's say, a double digit number, and we have to find out the remainder. Please do not get worried, because 24 can be written as 21 plus 3 to the whole power 629 by 7, where 21 gets ignored and I end up getting a single digit number once again, So no matter how complex the question is, I can convert it into a single digit number. Now 3 to the power 629. Now what I do, I will again try and reduce it in a way that I get something in the form of the denominator. So when I write it like this, I end up getting 209, because 209 multiplied by 3 gives me 627 multiplied by 3 square by 9, 7 in fact. So you have to be mathematically correct. So that 209 multiplied by 3 is 627 plus 2, 629. Now 3 cube is nothing but 27. 27 can be written as 28 minus 1 to the whole power 209 multiplied by 3 square divided by 7. 28 can be ignored. The next step would be minus 1 to the power 209, minus 1 to the power an odd number, which means it will be minus 1 to the multiplication of 3 square by 7. So what do we achieve? We end up getting minus of 9 by 7, which will give me minus 2. And since it is in negative, I told you what you do, minus 2 plus denominator, and you get the answer for your question. So that's how easily this can be achieved. I hope now this is pretty clear. Now, before I end this video, I'll give you one more category of question, which is sometimes asked in some of the relatively easier examinations. For example, if I give you 22 multiplied by 23 multiplied by 24 and divided by 7, and we have to find out the remainder again. So we have to find out the remainder of this question. Now, most of the students, what they do is they start multiplying these values. 22 multiplied by 23 and the final value multiplied by 24, and then they divide the complete value by 7 to get the remainder. Please understand, this approach is a tedious approach, and ideally we are wasting enough of time in solving this silly question. So what we do, instead of solving it this way, we divide the digits separately. So 22 by 7, what's the remainder? 1. Then 23 by 7, what's the remainder? 2. And similarly 24 by 7, what's the remainder? 3 divided by 7. So 1 into 2 into 3 gives me 6. 6 by 7 gives me 6 as the remainder. Please understand, this is an easier approach. Had it been instead of 2-digit numbers, had it been a case of a 3-digit multiplications, we cannot go on and multiply the numbers separately. Instead, in fact, we cannot even multiply those numbers with one another. Instead, we can divide them separately to figure out the remainder separately and get the answer. So this is just one silly but sometimes very frequently asked question in number systems. I hope you would have understood every bit of remainder finding concept. This is a very, very important trick that comes from number system.